often strikes fear into the heart of your AS computing student. Multiplying binary numbers, it's actually dead easy. It looks quite complicated, but it's actually dead easy. Okay, let's say we're doing a denary multiplication first. So 175 times by 16. Okay, what I would do, and you might do it the other way around. I normally start from the left, you might start from the right, but I would put down a 0, 1 5 is 5, 1 7 is 7, 1 1 is 1, 6 5 is 30, 6 7 is 42, 45, 1 6 is 6 is 10, add them up, 2,800. 175 times 16 is 2,800. Okay, that's how I do long multiplication. And you ought to be able to do long multiplication, I think. And binary multiplication is exactly the same. So let's do an easy one. Let's do 7 times 3. Okay, so 7 is this, 3 is this, and let's do the multiplication. So again, I'm going to start from the left. Put down a 0, 1 1 is 1, 1 1 is 1, 1 1 is 1, 1 0 is 0. Then do the next one. 1 times 1 is 1, 1 times 1 is 1, 1 times 1 is 1, 1 times 0 is 0. Add them up. That's 2, that's 3, that's 2. And the answer is 16 and 4, which is 20, and 1 is 21, which is correct. Okay, works exactly the same way. All you have to do, I'll do a different one this time, do 8 times 4, but I'll do it exactly the same way, except that I won't do 4, I'll do times 5. So we'll get enough numbers in here. What I'll do this time, if it's easy for you, I'll go from the right rather than from the left. So 1 times 0, 1 times 0, 1 times 0, 1 times 0. No, 1 times 1, honestly. Right? And then the next one, you put down a 0, 0 times 0, 0 times 0, 0 times 0, 0 times 1. 0 times 1 is 0. And then you put down 2 zeros, 1 times 0, 1 times 0, 1 times 0, 1 times 1. Add them up. And we've got 32 and an 8, which is 40. And 8 times 5 is 40. Okay? So whether you start from the left or you start from the right, so long as what you're doing is you're timesing by this and going all the way along, and then you move along the right number of spaces and do the same, it works. Some of you might have noticed that middle line there was kind of pointless because 0 times anything is just 0. Okay? And actually, multiplication in binary is dead easy because all you're doing is timesing by 0 or 1. And timesing by 0 is 0, timesing by 1 is itself. So let's do a really tough looking one. Let's do 15 times 30, no, not 32, 48. 15 times 48, that sounds pretty horrendous, doesn't it? Okay, 15 is that. 48 is a 32 and a 16. And all we do is we ignore the first 4 lots. So by the time we get to this one here, we put in our 4 zeros and we times by 1. And with this one, we put in 5 zeros and we times everything by 1. Add them up. That's 2, that's 3, that's 3, that's 2. Okay, and what we've got is this big number here. This is 512, this is 128, 64 and 16. So we've got 512, 128, 64 and 16. And we've got 10, 20, 3, 4, 5, 6, 12, 7, 720. Okay, 15 times 4, 48, 720, sounds about right. And it's actually dead easy. It takes a bit of practice. Again, just pick some random numbers, they don't need to be that big. Let's do 9 times by 12. Okay, so 12 is that, 9 is that. The first one, 1 times everything. Copy it down. Put down 1 0, which is not going to be zeros. Put down 2 zeros. Put down 3 zeros. 2, 3. Then do 1 times everything. 0, 0, 1, 1. Add them up. There we go. And we've got 64 and a 32, that's 96. Here, that's a 12. Add them together, we get 108. And if my 12 times table is right, 12 times 9 is 108. So it works. So you can ignore the ones with zeros in the middle, and you just push it in like you would with normal multiplication, and you can do binary multiplication, which is now everything you need to be able to do AS computing in terms of manipulating binary numbers.